we need to find the volume of the solid obtained by rotating the region bounded by y equals to x minus x squared and y equals to 0. And this is about the line x equals to 2. We're using the shell method, cylindrical shell method. Alright, let's go ahead and sketch this. To sketch this parabola, we just need to find the intercept. Alright, so if I solve for x minus x squared equals to 0, I end up with x equals to 0 or x equals to 1. Alright, so this is the x-intercept. Alright, so call this the x-intercept. Alright, and the y-intercept, we know already that if x is 0, then y would just be 0, so it's just the origin. Alright, so let's see if we can get a sketch. So 0, 0 and 1, 0 with somewhere there, so this is 1 and somewhere there. And now how do you know if it's going up or is going down? Alright, so you need to find something called the turning point. So turning point, you can just find the first derivative equal to 0 and see what value you get. So the first derivative will just be 1 minus 2x. And if you equate the first derivative to 0, you just have x is a half and y there will just be 1 over 4. Now y is 1 over 4, you know, is there at the top, so it means that the turning point is going to be up there. Alright, so it means this is what the shape is going to look like. There we go. That is your graph. So your graph will look like this. So this is y equals to x minus x squared. Now this is about the line x equals to 2, so I'll just denote that this is 2. Then I will draw a line across 2 and indicate that this is my axis of rotation. Alright, that's my axis of rotation. Now the process or the recipe is that you need to draw the rotated piece. We know it's going to be between 3 and 4 because look, it's 1 unit here and it's 2 units all the way there. So the rotated piece will be somewhere between 3 and 4. Alright, and how do we draw a shell? We say you draw the circular piece so that it touches the outer surface, and you draw the height of the shell so that it coincides with, remember y equals to 0 is just the x-axis, so the height should be the distance between the graph, so this parabolic graph and the graph y equals to 0. There we go, that's my shell. Alright, so this is a typical shell that you can draw. Now there's two things we need to know about the shell. We need to know what the radius is and what the height is. So I need to know what the radius is and I need to know what the height is. Alright, so for the radius, take note we're integrating here in terms of x, right? So the radius, we say the axis of rotation all the way to that graph there. So remember this distance from here all the way to this point there, remember that's the origin. This distance here is 2, therefore this distance needs to be slightly less than 2. Alright, so we'll just say 2 minus some x value. There we go. And then if you look at the height, is top graph minus bottom graph, and the top graph is just the parabola. The bottom graph is 0, so it's x minus x squared minus 0. There we go, you have your radius and your height. And therefore, you compute volume is integral. Again, this in terms of x is going to be from 0 to 1. You say 2 pi radius times height. Alright, 2 pi radius times height and dx. Alright, and if you simplify this, obviously everyone can multiply out and integrate. You should be able to get pi over 2. Alright.